Hi friends, welcome to the Unit 4 Day 4 Notes. Example 2 is finding the value of a logarithm. So we're saying assume that log base 10 of 7 is equal to 0.8451. So this is actually an approximation of what this value is. And what I want you to do is find the following. So I'm telling you, do this without using a calculator. So how would you do this without a calculator? Here's what you would do. First, see if you can manipulate this to make this number 49 to be 7. And I can do that if I take log base 10 of 7 squared. 7 squared gives me 49. Now I can use that power property, bring that 2 out in front, and that's 2 times log base 10 of 7. Now, at this point, I know what log base 10 of 7 is, so I can substitute, and I'm going to take 2 times 0.8451. Now, again, without using a calculator, I could just take 0.8451 plus 0.8451 to give me my final answer, which I'll do here off the side. 8451 plus 0.8451, 2, 10, 8, 9, 16. So I get 1.6902. And that is an approximation to what that value actually is. Notice that we rounded to 4 decimal places in this. We normally do when we're working through these. What about this one here? 70. Well, I could get 70 by taking log base 10 of 10 times 7. Ooh. Now I could do log base 10 of 10 plus log base 10 of 7. Now, log base 10 of 10, whenever you have log base to the same value, that goes back to property number 1 from that first page. That's going to always be 1. So this value right here is 1 plus 0.8451, which is 1.0.8451. And that's that. The next one, we're assuming that log base 4 of 3 is A and log base 4 of 5 is B. So find the following properties of logarithms, write your answer in terms of A and B. So here I have 15. Well, I can get 15 in terms of 3 and 5 by taking 3 times 5. So now what I have is log base 4 of 3 plus log base 4 of 5. Now we said log base 4 of 3. So log base 4 of 3. Well, that's this right here. Log base 4 of 3 is log base 4 of 3. So now I can substitute A in for this value and B in for this value. So this is just A plus B. It's only A plus B because this log is accounted for here and here. So that's just A plus B. So here, this log base 4 of 27, well, that's the same as log base 4 of 3 cubed, which I could rewrite 3 cubed as 3, or sorry, this whole entire thing, log base 4 of 3 to the third power is 3 times log base 4 of 3. Now, log base 4 of 3 is A, so this is 3A. 75. Ooh, how am I gonna get there? 75. So that's gonna be log base 4 of 3 times 5 times 5, or 5 squared. There we go. So I'm writing it this way so that when I split it up, I've got log base 4 of 3 plus 2 times log base 4 of 5. So again, log base 4 of 3 is A plus 2B. Now I have log base 4 of 45. Let's see, how am I going to get to 45 with 3 and 5? All right, well, if I take 45, divide by 5, ooh, that gives me 9, or 3 squared. So notice I'm just trying to see, okay, how can I use my numbers that I have here, 3 and 5, in these factors? Now these all happen to be factors of 3 and 5. That's why this is working out so well. So I have 2 times log base 4 of 3 plus log base 4 of 5. So this is going to be 2A plus B. Notice that these are very similar. They're very close to one another. with these values. This one, log base 4 of 3 minus log base 4 of 5. So this is just going to be a minus b. And then here I have log base 4 of 5 squared minus log base 4 of 3. At this point I want to showcase I can't take this value and say and turn this into b quite yet. I need to bring down log base 4. I need to bring down the 2 times log base 4 of 5 first before I do that. Log base 4 of 3. So this is 2 times b minus a. And then the change of base formula, this is another one that you're going to want to commit so that you know. For any positive real numbers, m, a, and b, with a and b not equal to 1. So m could be 1. You have these change of base. Now, what you most often want to do is use your calculator. And your calculator, if you just type in log in your calculator, using the log key that's on the main screen, most calculators just say this. And if I do log base 10 of 10, you get 1. Now, I said base 10. There's no base written there, so if there's no base there, we know that it's base 10. Well, what if I want it to convert to a different base? So this log base b of m, what I can do is I can divide these two values. And what do I mean by that? Well, if I take log of 4, let's do log of 8, divided by log of 2, and this is the same, the reason why it came out to be this is the same as 2 cubed to give me that 8 value. So this is just another way to write out bases, change of base. This allows us to use our calculator to evaluate. We'll be doing this often. This works really well for calculators that are older, that don't have a change of base method that's already included. This calculator does under the math menu. If you go down to the bottom, I actually went up twice to get to it instead of scrolling all the way through. And then this gives me a spot where I can put these in. So this is, those are represented as the same thing. So you can use this division principle here to help us go through and solve. Notice that that's different than if I just did log of 8 halves. That's different. Log of 8 halves is log of 4, and log base 10 of 4 is not 3. It gives us something different. So just note that these are very different. Spend some time again, these with flashcards. Base E means that we're using the natural log. Base A means that we're using this to come up with a new base. So we can actually use this to convert to any base that we want. You'll see me do this often. Again, good things to know. Whenever we solve logarithmic equations, we need to verify solutions because we could find extraneous roots. And this is the same idea when we multiply or increase the power, we're introducing the possibility of an extraneous solution. So it's always good to check them when you get done to verify that it's actually a solution. All right, next video, we'll actually start solving logarithmic equations. I will see you then.